Okay, so this is Introduction to 3D Printing with the Warren County Library System. You already have an account. Oh, I see another. Is that you?
No.
Okay, I have another person who's trying to enter, but they don't have a name, so I can't let them in. All right, so once you have your account, let's just talk a little bit about what 3D printing is. So 3D printing is what we call additive manufacturing. And what that means is that, that basically we make three-dimensional objects, solid objects from a digital file. And we kind of start from nothing and lay down layers of material, in this case, a plastic, until your whole object is made. So each layer is very thin. It stacks on the layer before it from the base up. And as you can see, it's not necessarily 100% solid. We often will print the outside as a solid piece, and then the inside will be kind of a cross section, and that just saves material without, reducing any strength. I've got a little video, and I'm gonna cross my fingers if this works, because as we know, things can be a little challenging sometimes. I'm just gonna make sure. Okay, so you let me know if the sound comes through. If it doesn't, we'll make it work.
Okay.
Okay, and let me just make sure. Here we go. I'm gonna switch my audio. Okay, yeah, it should work. I think I have everything set properly.
I'm not able to hear the audio.
No hearing? Okay. Try that one more time. Okay, so it should be allowing me to share computer sound. Try setting it again and optimize. Okay, let's try one more time.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And don't forget to watch.
Okay, so that's kind of like just a quick overview, and I just like the visuals for that because I think it helps really bring home what 3D printing is all about.
Yeah, it's like really amazing, right? It describes everything, how things are being made and the uses. It's amazing.
It is. It's really pretty stunning that we can do all of these things with this one technology. So it's not, I mean, when it first kind of came out, people were like mostly using it for just I'm just going to admit, Melissa, people were using it for kind of hobby stuff, you know, and
Yeah.
it was like high-end engineering and like hobby. And now, welcome, Melissa. And now we're seeing more and more practical applications for 3D printing, which is pretty stunning. So when we talk about 3D printing, sometimes you'll see the term FDM or fused deposition modeling used to describe it. And what that means is that each layer has to attach to the previous layer, fuse together. Otherwise, you end up with a situation where you get a mess because nothing sticks together. There are actually 7 types of additive manufacturing, and 3D printing is just one of them. It uses really thin material on a coil, which is kind of wound around that big, like you saw that big roll. And it goes through, I'm going to just move this out of the way. Okay, moving this. If you can see the picture here, we've got a hot nozzle, and that gets up to like over 200 degrees Celsius, so it gets really, really hot. Usually the bed here, this table that moves, is also quite warm depending on what you're printing. So we do try to make sure that we're very careful around a 3D printer because you can get burned. But the filament, the plastic comes in down through this nozzle, it's heated in that nozzle, and then it's laid out thin layer by thin layer. You can think of it almost like a hot glue gun if you've ever used that. And if you lay down like a hot glue gun, then you can do a layer on top of that and up and up and up. And 3D printing works in kind of a similar fashion. And the important thing is that the layer underneath is just cool enough that it doesn't squish when you put the next layer on, but that it is still warm enough that they stick together. And all of that is handled by the computer that actually runs the 3D printer. So everything hardens very quickly. So basically by the time a print is done, you can usually lift it off the bed and have a finished print, which is pretty amazing too. All right. So what do we actually use to 3D print? And this is a picture of one of those rolls of filament that I mentioned. The library has lots of different colors available, a couple different types of material, but the 2 most common materials that we use for 3D printing are ABS, which is a petroleum-based filament, very resistant to high temperature. It's pretty inexpensive and it's very strong. So a lot of people like this if you're making something that really needs the strength and is able to last for a long time. The downside is that it does need kind of enhanced settings to be able to be printed. So like it has to use a heated bed and things like that. So it uses a little more energy. It is toxic because it is petroleum based. So you can't use it for food-based applications. We don't recommend it with children just because if they're going to accidentally put it in their mouth or anything, we don't want that. And it can warp a little bit more. So if you're going for a really delicate print, sometimes you're not going to get as good a result. ABS is really meant for, I want to make a screwdriver, you know, and print it. PLA, polylactic acid, is actually based on biodegradable corn. So it is a biodegradable, more sustainable filament. It uses a little bit less energy to print because it prints at a lower temperature. It's also inexpensive, but it isn't as sturdy because it can melt at a lower temperature. And that means that like you can't, while it's food safe because it's generally considered you know, a safe material, non-toxic material, you can't make a coffee cup out of it because your coffee will literally melt your your filament. So it doesn't warp as much though. So it's really nice for hobby printing and for figures and for things like that. So when you design, and especially when you send your print in to be printed by the library, you just kind of want to think about which you prefer because you will have a choice of what kind of filament you want to use. There are also all kinds of wood filaments, metal filaments, flexible filaments, conductive materials. We have a limited number of those just because we don't get a lot of use for them. We do have a flexible filament that we can do printing in, but mostly we do ABS or PLA. So what can you actually print? And honestly, anything that you can imagine and design, we can print. More or less. You don't want to make anything that's too tiny. And I'm going to introduce you to our 2 3D printers and give you an idea of their kind of specs. But anything that's very, very small and very, very detailed probably isn't going to print very well. You also don't want to make anything that's too big for the actual printer. Our large printer, our Delta style printer, can print up to 10 inches wide by about 14 inches tall. So it's got a pretty good range. But if you're printing something really long, you're going to have to break that down into multiple pieces and attach them rather than try and do one large print. You do want to think about the final strength of your product. So if you are using something that needs to hold up another item, for example, you may want to, when you send that print in, say, hey, can you use ABS, or hey, can you use a really high infill so it's almost a solid piece, as opposed to a quicker print that might be less infill. So sometimes it can be really helpful if, when you're sending a print to me, you tell me what you plan to use it for, and I can guide you as to what settings will give you the best results. Some items will need what we call post-processing. So you can see this skull I have over here as an example. This would print pretty well, but anytime you have overhangs of over 45 degrees, what's going to happen is the bottom layer will cool. The next layer is going to be offset from that layer, and it's melted plastic. It's just going to droop down. Oops, sorry. And so you really want to think about that in your design, because if you have a lot of like overhanging bits, they may not print as well. Now we can put in supports for that before I print it, but you're going to have to break off those supports. You're going to have to sand it and clean it up a little bit, and you're going to pay for that PLA or that filament as well. So as you design, you want to try and design in a way that has as few of those kind of overhangs as possible. Like I said, got to keep it under 45 degrees. If it's like a 30-degree angle, 15-degree angle, it's not going to be a problem. But once you get past that, you start needing supports. And again, you can print in multiple pieces to avoid some of that too. For most of our 3D printers, you can print in one color. Our newest printer, the Prusa, does let you print in two colors, but it's literally, you could print like the bottom half in one color and then the top half in a different color. It can't print like teeth a different color than the rest of the skull, for example. So it's kind of basic in that. We are working on funding, hopefully, to be able to add more color printing. But for now, assume you're printing in one color, maybe two. And when I say the geometry, that's what I'm talking about. If you classically, like I would say, if you want an action figure where somebody's holding their arms out, you want to consider that something has to hold that arm up. Also, we will not print any kind of weapons of any kind. So even if it's just a sword for a costume, I am not allowed to print that for you because it could be considered a weapon. So I can print a cool looking hilt, and then you can add a cardboard blade or something later. I cannot print any kind of a gun, nothing that could be considered a weapon. We will not print it. So just so that you know that, even if it's just for a costume. All right, so our actual printers. This is the Rostock printer. This was our first 3D printer. It is, this is our larger printer. It's what we call Delta style. So you see these kind of three arms, and it's got this tube that feeds the filament down. The strength of this kind of a printer is that it can do really big prints. So this is something that you can do 10 inches wide and like 12 or 14 inches tall. Now, that might take a really long time, but it's a really nice printer in that respect. Now, right now, this is in the makerspace. I am not able to use it. I'm not able to print on it. But we will hopefully be back to doing that very soon. This printer, I should let you know, has slightly less resolution than our other printer. So if you want something that's like really, really detail printed, you might want to ask, like, let me know, this has a lot of detail, please use the detail printer. If you're printing something really big or something that you're not really worried about the detail, the Rostock is great for that. This is the other printer. This is our Prusa. This is what we call Cartesian style 3D printer. So it doesn't have those long arms. Basically, it works by moving the bed instead. So in this one, the bed stays steady and the arms move around and put the filament down. In the Prusa, both the head, the nozzle, and the bed move to create the print. So you get very, very nice detailing with this. And so I always recommend, if somebody's doing figure work or anything like that, you definitely want to ask for the Prusa. You also want to ask for the Prusa if you're doing any kind of specialty filament. Like I said, if you're doing ABS, Ninja Flex, if you want multiple colors, this is going to be the printer that we're going to use it on. But what you need to understand is that it can't do as large a print. So it can only do about 8 inches wide, and it almost gets to 10 inches tall, but really, realistically, 9 inches tall. So you get the detail, you get more options, but it's going to be a smaller print. So just something to consider. And again, if you're not sure, all you do is say, Sandy, this is what I'm kind of aiming for. What do you recommend? And I'm happy to help you out like that. So where do designs come from? Obviously, you can make your own, but there are lots of 3D designs available for free out there that you can get started with. And sometimes if you have an idea, but you don't know where to start, you can go to these sites, find a file, take a look at it, and then you can just like rework that file. You don't have to reinvent the wheel. And sometimes that can save you a lot of time. So Thingiverse tends to be my go-to. It's been kind of the hub for many years, but a lot of others are coming in, like Prusa, that the 3D printer maker. They actually have their own site now where you can share designs. My Mini Factory is tied directly into Tinkercad. Shapeways is another one. They actually have paid options. So if you don't want to print through the library because maybe we don't have the metallics, filament that you want, Shapeways, you can actually order it and they'll ship items directly to your house. And then there are a couple of others that are kind of, Yegi is growing a lot. Colts is growing a lot. I tend to stick mostly with Thingiverse or with Prusa, sometimes with Shapeways. So my point is, if you're looking for a file, instead of reinventing the wheel, search for it. Search for a 3D printable file of Boz or whatever, and see what you find. It might give you inspiration, and it might also have a file ready to go. Now, if you want to make your own file, you're going to need to use computer-aided design software, CAD. There's many different CAD softwares out there. I always recommend people start with Tinkercad, and that's what we're going to use today. And the reason for that is that it's really simple to use. It was actually designed originally for kids, but it's quite powerful. And it's totally free. And you can use it on any website. You can use it on a tablet. You can use it on your computer. So Tinkercad is really easy to start with. But what's cool is that it is part of the Autodesk family, and Autodesk is kind of the most popular CAD software out there used by engineers and architects. So if you get used to Tinkercad, it's very easy to kind of jump up into the more complex programs, and you'll already have an account ready to go. Morphe, I really like. It's available for desktop and for tablets like the iPad. You do have to pay for it. The big cool thing about Morphe, it's very similar to Tinkercad. It's pretty easy to use, but it has a VR function and an AR function. And that means that it can work in virtual reality and alternate reality. And if you are designing a piece, say for your home, you can switch into AR mode with a touch of a button and actually hold up your iPad and see that piece in your room. So for certain applications, that can be mind-blowing, and kids, frankly, love it. It's fun. So if that's something that you're interested in playing with, Morphe may be the way to go. I do personally use Morphe on my iPad because I really like it on the iPad for that reason. Now we're getting into kind of our more professional tools. SketchUp, and I've linked all these, and I will send you the link to this presentation so you have all of it. SketchUp is very popular. It's very powerful. It was originally designed for architects doing 2D work, but it's grown a lot. Some people absolutely swear by it. It's the only thing they'll use. And it is a pretty powerful tool. Blender not only has like 3D printing and CAD capabilities, it does have really powerful 2D engines. You can do animation and VR. So it is much more challenging to learn than Tinkercad. But when you start finding that you're running into the limits of what Tinkercad can offer, Blender may be right for you. Now, SketchUp, Blender, and Fusion 360, which is kind of the grown-up version of Tinkercad because they're owned by the same company, a lot more powerful. This is the industry standard. Fusion 360 and Autodesk are the standards if you are in engineering. But really, it comes down to they each have their own interface, and some people just like one more than the other. And you may have to try them. They all have free trials. If you are still in school, you can usually get a free version of these. So this is kind of where you'll go once you kind of get used to the idea of CAD in the first place. Okay, so that's me talking. What we're going to do next is we are going to, if you haven't already started Tinkercad, you're going to go ahead and open up Tinkercad in a window. You're going to get signed in. If you already have your account, if you already made an account, use that. If you want to join our class, you can do that. You'll notice under Learn, there are some starters, and that's where I always recommend people start. I know that they seem kind of boring, they can seem kind of simple, but to learn the environment, this is going to be your best hands-on tool. I'm going to switch over to Tinkercad now and give you just a real brief kind of introduction and overview to what that environment is like. Do I have any questions right now before we kind of switch over? Doing okay? I'm not throwing too much at you too fast, I hope. Okay. I am going to switch my view. Let's see if I can do this without too much trouble. Where'd it go? Oh, no, I'm gonna have to stop the share and start the share again. Sorry. Just because it doesn't want to exit out. Okay. So, and I'm gonna screen share again, and I'm gonna show you Tinkercad. Okay. So this is our Tinkercad window. Just kind of move that out of the way. So I've logged in as my library account, and you can always find me that way. I am SW Makerspace. So you can look for designs that I do by searching for that username, actually. I've gone into the Teach section here, and these are our starters. If you want to go straight to making your own design, you're going to click on the Tinkercad logo, and that's going to open up your gallery space. You're going to click on, you're going to keep it on 3D designs. There are, of course, other things that you can do in Tinkercad, including lessons that will lead you step by step through creating a project. But I'm just going to start with create a new design and kind of go over some of the basics. Okay, here we are in Tinkercad. You'll notice up in the corner, it'll have this weird name. You can change that at any time. So I'm just going to put in new design. It doesn't matter what you call it. I do usually suggest you change that though, because the names tend to be nonsense and you'll forget what it is that you created if you don't actually name it something useful. All right, so what do you have on your screen? This is our work plane, clearly labeled. This you can kind of think of as the bed of the 3D printer. It's the base where everything is going to be built up from this base. Over here, okay, you have a bunch of basic shapes that you can drag in to our design. The ones that are gray, like this with the stripes, they're what we call holes, which means they cut out that shape. These are solid shapes. So they would be built out of the plastic. You can change the view of your work plane really easily with this little box. Top lets you look down from the top. You can actually hold it and move it around. Okay. You can zoom in. And if you have a wheel on your mouse, or if you're working on a tablet, it may be a little bit different, but these buttons always work the same way. You can zoom out. You can look from underneath and all kinds of stuff. If you get lost, and that happens sometimes when you're working in a 3D environment, you're just going to hit the home button, and that will always bring you back to the same view. Now, I should mention, when we work in 3D printing, we usually use the metric system. So everything is based on millimeters. And you can see that down here, your grid. You can snap your grid to different sizes depending on the detail of your work. Default is 1 millimeter. But if you're doing really detailed work, you can bring that down. If you're doing something that's more of a rough sketch, you can bring that up. Under Edit Grid, you can choose to go to inches. And this bricks, that means that's for Lego settings. You can actually design with Lego instead if you prefer. And some kids really love that. So if you want to switch to inches, you can. I tend to keep it to millimeters. And what I tell people is the easy thing to remember is that 26 millimeters is an inch. So that's very similar to 25 cents and 4/4 make a dollar. So roughly 100 millimeters is going to be 4 inches. I find it pretty easy to kind of keep that straight once you practice with it. But if you feel more comfortable switching over to inches because that works better for you, you can absolutely do that and just hit update your grid. It's not going to affect anything on my end when I go to print it, is my point. Some basic functions up here. You have your cut and paste, the same as you do in Word documents, Control-C, or you can click copy. Paste. This duplicates. Duplicate and repeat is really useful if you want to change the angle of something, because it doesn't just cut and paste. It continues the same rotation or continues the same track that you were on. That's kind of a more advanced piece that you might get to. This is our trash. So anytime that you have something you want to get rid of, you click on it, you hit delete, it goes away. This is your undo button, always a good thing. Don't worry, nothing's permanent. And this is your redo button in case you undid it and then decided you liked it. Over here, this is show all. So sometimes you may have certain pieces hidden. It may be tough to see them. The show all button will reveal everything. Grouping or merging is really important. As you combine pieces, I'm going to show you this in a moment. As you combine pieces, you need to group them to make them one solid object. This is especially important if you want to cut out a shape from your object. Ungroup if you need to take them apart again because you want to adjust something or move something around. These align functions I'm going to show you in a moment, and they allow you to line up your pieces center, left, right. Very helpful because it can be hard sometimes to see in 3D if everything is lined up the way you want. This makes it very simple. And then you've got your basic mirroring, so horizontal, vertical, that sort of thing. When you're all done, you're going to hit export to download your file, and that digital file is what you actually send me for printing. Now I have this set to basic shapes, but there are all kinds of other things that you can, including pieces that are all done. Like the Smithsonian Museum has actually put up a whole bunch of different skulls and things that you can print based on their collection. I usually start with our basic shapes and then add more if I need. So how does this work? Really simply, I'm going to take a real basic shape here, just a box, and bring it into the center. I'm going to move my little thing here. Now I can change the color. That's really just personal preference. The color that you have here in Tinkercad does not affect the color it prints. I set that on the machine itself. So you're really free to work with as many colors or whatever colors you want. When I click on one of these squares, okay, these squares are all going to allow me to resize my box. So if I click on this bottom square, you can see right now this box is 20 centimeters by 20 centimeters. Maybe I want it to be a little bit bigger than that. Maybe I want it to be 50. So I can drag that, and I don't have to make it equal. I can also click on that box and input exactly how many millimeters I want. So if I want to make a rectangle that is exactly 25 millimeters by 50 millimeters, I can do exactly that. Now, this is quite tall if I look at it from the side. But again, if I click on it, this box on top, I can change the height, okay, to whatever I want. And again, I can type right on in there. Like I want something kind of thin. This little cone is very important. Sometimes it's very easy to get confused and accidentally click the cone when you mean to click this box, or vice versa. The cone actually lifts your piece up off the bed. If you sent this to me and I tried to print it, this would not work because it's not attached to the bed, and you just get a mess of filament dripping down. So every now and again, just take a second and make sure that you're on the bed. Again, in this box, you can put 0, and that will mean that you are right against our work plane. Now, there are some times you may want to go above or below, especially when you're cutting holes and such. But for the most part, you want the base of your design to be on the bed. You can, however, use this to build other pieces onto your creation. For example, if I bring another box over here, and I want that to be stacked on top of my work plane, I'm going to zoom in a bit for you. I can use that cone and lift it up. You know, now it's above, I can lift it so it's exactly even with it, or even into that piece. If I do that into the piece, they will merge together as one piece. Let me show you that. So I'm going to just select both my pieces, which I did by drawing a box with them, or you can select one and pick the other. And when I go to group, they all become one fused piece now, and the color will change to one color. And now I can move both of them together. I'm just going to go to home, and move it back to the center. Okay? So you always want to group your pieces when you're done. You can group these two, add more things, group again, and when you ungroup, they'll ungroup in that same order. So sometimes as you're building, you might want to group pieces even though you're continuing. Now let me use a little box here. I'm going to drag in a cylinder. Okay, and I'm just going to drag it right over that piece. And I want to show you what happens when you add a hole. Okay, and you can make literally any shape of hole if you click on that gray stripy lines. I'm just going to go ahead, and when I group it now, you see how that hole cut out that same shape on that piece. And again, this is where sometimes you want to use the cone and drag that hole deeper just to make sure you cut all the way through. Now, you do not need to cut all the way through. I'm going to ungroup. I'm going to zoom in a little bit. I know that my base here is 4 millimeters. So if I take that cone and drag the hole up, say 2 millimeters, and then group it. Oh, I didn't do it well. Try that again. Oh, see, I made this. I think I grabbed the wrong thing, didn't I? See, this is why you got to be really careful when you're working with these. I accidentally grabbed the wrong piece. So I'm going to grab this hole, move it up 2 millimeters, select all of it again and group. And now you can see I didn't cut all the way down. I made kind of like maybe a spot for a tea light to sit. Okay. Now imagine, if you will, I'm going to ungroup this. Perhaps I wanted to make sure that all of these are lined up along the center of this piece. I would select all of them, come up to a line, and you see all these dots, okay? And those are all the planes along which I can align these items. So if I want to line them up along the center, horizontally, I can just click that button and you can see it adjusted it just a little bit better than my eye could. So these are now perfectly aligned along the center. And you can do that on all 3 axes, our X, Y, and our Z. So that's a really helpful little function because it will really save you a lot of time trying to like eyeball those kinds of things. So that's kind of the very, very basics in and out of using these tools. And you will notice, actually, if I can get it to just, oh, yes, I'm done aligning. Thank you. If I select, really wants to do that. Over here, you have some settings you can do for each piece. Like you can adjust the size here using that slider. You can adjust the bevel, which means you can see that it's actually beveling the outside edge, which is a really nice feature, especially if you're designing something like a button or whatever. And you can change the number of segments. I'm going to change it to a whole so you can see this a little better. But you can change the number of segments, which will affect how smooth your creation is. So you can see as I increase the segments, it gets to be a little smoother around the outside. So, again, it comes down to what you're creating and what you're creating it for. Okay, so that's like the super quick introduction. I'm going to stop sharing my screen, and if you have any questions, you can unmute yourself. You can ask. If you want to share your screen, if you're having a little bit of trouble, we can do that. Oh, and I forgot. I'm sorry. I completely forgot the most important thing. I apologize. I'm going to group these. When you're ready to send a file for printing, you come here to export, and you're going to select either everything in the design, if you want all of it, or just the individual piece you want printed. And you're going to select STL. I can only accept files that are STL files because they have all the measurements encoded into them so that I know that they're going to print correctly. You just download that and it will be in your downloads folder on your computer. You can see it's right there. You can't open this like in a web browser or anything, but you can attach it to an email. And that's the last thing I just wanted to fill you in on. Again, right now I'm not at the makerspace, but soon, hopefully, we'll be able to start printing and doing curbside pickup for 3D printers, 3D printed pieces. So if you want to send your file to me, you're going to download it as a STL again. and you are going to email it to 3dprint@warrenlib.org. I'm going to review it. I'll send you a cost estimate, find out what type of filament you want to print with, all those sorts of things. And then I'll print it. It will cost you 5 cents per gram. Again, you will have the opportunity to say yes or no before it's printed. And that is based on the actual weight of what you created. I weigh it on a little scale, just like you would anything else. Most prints are pretty inexpensive. You can print a lot with a gram of filament. So most of the prints we typically do are under $2. So just to give you an idea, it's not an expensive process. It may take a while, especially right now. I don't expect I'll be able to get prints out to people until the end of July, maybe August. I will try to push to get that faster, but that's kind of the timeline I'm looking at this point. Okay. So if you have any questions, I am here to answer them. If you are tired of hearing me talking, that is totally okay too.